Welcome back to Sudoku Sunday, where today we are solving Octagon Cage Match by Willpower. Let's get right into the rules. Normal Sudoku rules apply, and factor regions, numbers in dash regions multiply to the number in the top left corner of the region. So instead of killer sums, we have multiplication. So, for example, this 8 cage, instead of being a sum of 8, it's a multiply to 8. So I suppose the options we could have in here are 4 and 2 or 1 and 8. That's pretty simple. Let's get solving. So I assume, just like with sums, we want to look at big multiples and small multiples. Like here there's 45. I don't think there's another way to make that besides 5 and 9 with Sudoku numbers, so we can do that there. 42 also I think is unique. That is 6, 7. Put your "she said the funny haha" comments down below now. But the fact that this is 6, 7 means that this 6 cage can no longer be 6, 1. So I think that means it has to be 2, 3. Pretty good. 45 again. That's going to be 5 and 9. So 8, like we said, is going to be 1, 8 or 2, 4. I think it can be either one right now. Something else to look at is where can we put 9s? 9 does not factor into 30 or 24 in 3 or 28, and we already have this 5, 9 that looks here, so I think we just place the 9 in box 4, and then again the 9 doesn't go in the 28, so that's a second placed 9. And we just said 9 doesn't go in 30. And then 9 can't go here through being in the box already. So the 9 is going to be in one of these places. 18 cage is looking pretty good for the 9. 9 and 2. Very easy. How else can we make 18? 6 and 3. And I think that's it. We'll keep an eye out for that. 16 cannot be 4 and 4. That would be 2 4s in the same box. So it can be 2 and 8. And that's it. So what do we have left? 1, 3, 4, 6, and 7. 7 definitely cannot go in the 12 cage. So 1, 3, 4, 6. What multiplies to 12 out of those? The answer is 1 times 3 times 4. It could be 1, 2, 6 because the 2 is already used up. So this, once again, is 6, 7. I think Willpower made this puzzle just to troll me. Let's see. Although I suppose most of the people who are young enough to think 6, 7 is funny probably aren't listening to my Sudoku video. But if they were, I'd be pretty happy. We need more young people in Sudoku. It is such a fun game. Expand your brain. Let's see. So 7 can't go in any of these places and can't go in here because it cannot go in the 12 cage. So we have a 7 here. 6 could go in the 12 cage. Like we said, it could be 2, 6, 1. I think a 1 has to go in the 12 cage. Since it's in 3, I don't think it's possible to have 12 in 3 multiples without a 1. So I think we're going to take the 1 out of here. And in fact, that means this does have to be 1, 2, 6, because if it was 1, 3, 4 again, then this cell here couldn't have any value. Everything would be ruled out. We can take the corner pencil marks out of there, and then this 2, 6 looks at this 2, 8, gives us 8 and 2, all nicely placed. So you have 1, 2, 6 triple and a 5, 9 pair, which means this is 3, 4, and 7. And we cannot put 7 into 36. That just does not work. So 7 has to go here. We can put 4 and 3 into 36. That'd be 3 times 12 out of these two, or 4 times 9 times 1. Let's look at some other sums. 35, that is 7 times 5. The 5 is not here, so this is the 7. 7 cannot be over here, and it cannot be in the 8. So 7 is going to be here. That gives us an X-wing on 7s. Although we already could kind of tell that 7 could only be in these two places. 28 cage does work for 7. Seven times 4 times 1. Okay. Let's look at this 30. I feel like 30 is pretty restricted. What are the factors of 30? We can put 5, 6, and 1 pretty easily. It could also be 5, 2, and 3, and I think those are the only possibilities. So it has to have a 5 in it, and a 5 sees this, and a 5 sees this. So here is the 5. This is either going to be 2, 3, or 6, 1. And it can't be 2, 3, because this 6 cell is already 2, 3, so we can't point both a 2 and a 3 at it. So this is 6, 1, which looks down at the 6, 7. And clear that up, and this 7 looks up here. And this 1, 3, 4 triple looks at the 1, 6. So this is the 6, and this is the 1. So what is left in this box? We have 7, 2, 3, 4, and 8. 2, 3, 4, 7, 8. We already know 7 can't go in here. Can 8 go in here? I don't think so, because the smallest multiple we can make now, if 8 was in it, was 8 times 2, which is 16, times 3, which is much bigger than 24. So this is going to be 7, 8, and 8 doesn't go into 28. So this is going to be the 7, and this is going to be the 8. And the 7 clears up this 6 and 7 over here. Means this is 2, 3, 4. Make sure that math checks out. 2 times 3 is 6, times 4 is 24. Lovely. 3 and 4 in this triple. Make this a 2. Lovely. And how do we make 28? Our options are 3, 4, and 1, which means the answer is going to be 7 times 4 times 1. Makes this a 3 and this a 4. Over here, we have 7 and 8, some order, and these 3 are 2, 3, and 6. We don't know a lot about them. Alright. Let's look around at some more cages, I suppose. 30, we already decided when we looked at this 30 cage, has to have a 5 in it. It can't be this bottom square, so the 5 is one of these. So it's either 5, 6, 1 or 5, 2, 3. Which is going to be very good here. But that does push the 5 into this central column here, and I believe this is an 18 cage? Yes, that's an 18 cage, so this cannot have a 5 in it. This 20 cage has a 5 in it, which means it is 5 times 4. Then looks up here and fixes this 1, 4. Again, this 18 can be 9 and 2 or 6 and 3. But both are still possible, I think. Certainly looks like it. This 8 cage can no longer be 8 times 1, which means it's 2 times 4. Which means this is a 3 and this is a 2. 2 out of here. What other cages do we have? We have this 20 cage and this 36 cage. Can we do anything with the 20 cage? So the 20 cage can't have a 1, 2, or 6 in it. Obviously 7. 4, 5. Very good option. Is there any other potential options? I don't think there is. I think 20 is just 4, 5. Makes this a 9. 5, 9, 5. Very good. Two. This box is going to go up here. If 2 is in the 36 cage, we could have 2, 3, and 6, which is still possible. We could not have 2, 4. Can this be a 4 anymore? I'm going to delete this so we can see the 36. So if this was a 4, these would have to multiply to 9. And the only way to do that is 3, 3, which is impossible in the same box, or 1, 9, which is not allowed anymore. This is a 3, 4, which means these other two cells multiply to 12. It's going to be 2, 6, or 3, 4, and we know it can't be 3, 4. There's a 3 here, so this is the 2, and this is the 6. Lovely. And what is left is 4, 8, and 1. This is not 4. All right. What's left in this column, I think, is a decent question. We have a 1, 5, and 6. These two cannot be a 6. Means our 6 goes right up here. In box 7, we have 1, 2, 3. We need 4, 8, and 9. Is there anything? Yep. We can take 4 out of here. Gives us a nice 4 here. Which gives us 5, 4, 5, and 4. This here is going to be 1, 3, 8. It can't be 1, so it's going to be 8. Doesn't very help us in the column, but it's good to write down. Okay. We need to keep checking in on the 18 and on the 30. The 30 is 1, 6 or 2, 3, and I think both are still possible. Ooh, if this had a 1 taken out of it, it would be very good for us. But this 2 looks at this 2, 4, so this is a 4 and a 2. Let's just do a quick flick through all the numbers. Close, but not quite. 3. We could mark these. All of these are known. We need a 1 and a 5 here, which we can mark. 1, 5. This is not a 1. And then here is 3, 8, 9. This is not a 9, and this top one is not a 3. Here, we need 3, 4, 8, and 2. And if we take a look at the 30, we cannot have 8 or 4 go into 30. That just doesn't work, which means it is 2, 3, and 5. Makes this a 5, because it can't be 2, 3. This is a 2, 3, and it can't be a 2, so this is a 3, 2. Not a 3, which means this is a 3. Four 8's there. 1, 4, 8, 9. 1 can't go here, and 1 is in one of these two places, which points there, getting us a 1 in the corner. Going to be an 8 or a 9 in the row. Now the only box we have left is the 18. 3, 6 or 2, 9. This can't be 2 or 3, so this is 6 or 9. And this is 2 or 3. Are so close. This 5 is this 1, 5. The 1 out of here. Seven in this row can't go here, so it's here. Also here, is that all the 7s? I believe it is. Very nice. This is 1, 6, 8, 9. This can't be 1, 9, so it is 6, 8. This can't be 1, 6, so it's 8, 9 actually. 8, 9 gives us the 6 here, 9 here. 9 times 2 is 18. 6 gives us 1, 2, 6. Ooh. 9 gives us 8, 9, 8, 3, 8, 4, 1, and the 3, 1, 4, 8, 8 goes here, 9, back to the 8s and 9s we go. Alright, what is left? 4 goes here, and 6 is here. This is the last one in its row. The 3. This is the last in its box. A 9. What is left here? 3, it's a 2. 3 and 6, this 6. This a 3, 6. 8, C is 7, 8. We need a 1. And our very final digit is an 8. There you go. That was a very fun new rule set for me. Thank you for solving along with me. That was Octagon Cage Match by Willpower in 21 minutes and 20 seconds. I'll see you guys next time.